Hello everyone, I'm Koteshwar from Tektronix. I'm an RF application engineer and a tech enthusiast. In this video, we will look into what are trace points and detectors in a spectrum analyzer. Before jumping into trace points and detectors, let us see how spectrum in a spectrum analyzer is computed and displayed. Let's focus only on x-axis, which is a frequency axis. The start point of the x-axis, which is frequency axis, and stop point on a frequency axis is determined by center frequency and span. Start is center frequency minus span by 2 and stop is center frequency plus span by 2. So this determines where the frequency starts and ends. We all know from our engineering days, the FFT, the x-axis frequency axis is discrete in nature, meaning we only know power level at certain points on x-axis. It's not continuous. So there will be a fixed points on x-axis. Do we have a control on choosing where these points exist on frequency axis? Yes, we do have, which is called RBW, the resolution bandwidth, which basically determines from start frequency what is the resolution or what is the gap for the next point. So it goes on until the stop. So let's take an example and calculate how many points. This points literally also means the FFT points. So let's calculate how many points we will have for a certain settings in a spectrum analyzer. So let's take a frequency at 1 gigahertz and a span of 10 megahertz and a resolution bandwidth of, let's say, 1 kilohertz. So how many points would be there? It will be 10 megahertz span by resolution bandwidth, which is 1 meg by 1 kilo, which is 1 kilo points will be there on a spectrum analyzer. 1 kilo points is not that huge, but we are setting the spectrum analyzer in a very basic way. So let's push it to max extent. Let's put everything max. So let's take max span. So we have 18 gigahertz spectrum analyzer, so max span would be 18 gigahertz, and let's keep the minimum resolution bandwidth, which is 1 hertz. So 18 meg by 1 hertz, which is 18 gig points. So generally, to represent a point in any software, we'll use floating point, which the least would be 32-bit. There are 64-bit as well, but let's take 32-bit. So 32-bit corresponds to 4 bytes. So how many points? We already have 18 gig points we need to display. So 18 gig into 4 bytes we need to show somewhere, which in general is a RAM. So 18 gig into 4, which is, is it 72? It's around 72, isn't it? It is around 72. Well, obviously we don't have that much RAM available, and obviously this is not the way a spectrum analyzer works, obviously. So how this problem would be solved? And this is a general setting. We'll keep max span every day in our spectrum scan. So how would a spectrum analyzer handle this issue? Well, we'll not display all the points. We'll take only specific or a fewer points. How to choose these points? Well, we divide the spectrum display into segments or buckets, and we'll take one from each bucket or segment. So do we have a control on choosing how many segments or how many points to display? Yes, we do have. If you go to spectral settings, there is a sub tab called traces. If you go into it, you will find trace points. It starts from 801 and it goes more. And the more the spectral points, the more the accuracy, isn't it? So this is the way we can set the number of trace points on a spectrum display. Now we obviously eliminated few, or we chosen only to show certain points to be displayed because we don't have memory to display all the points. So now we divided into segments. But again question comes, what sample to be taken from the segment? Is it a center sample, starting sample, or the ending sample? The answer for it is, it depends on what detector you selected. Detector meaning what you detect from the segment. For example, if you choose sample, it takes the sample which takes the point which is exactly at the center of a segment. If you choose max detector, of all the points in a segment, the max value would be picked. If it is min, of all the points in a segment, the minimum value would be picked. There is detectors like average detector, where the average of all the points taken and would be displayed as a single point. There are many advanced detectors like CRISPR peak detector, which is used for EMI/EMC view, which has different properties. So basically the detector gives you what sample in a segment to be taken out, and the trace points, how many segments to be divided into. Hence the summary. If you like this video, please share and subscribe to our channel TechHint. We'll be posting many more videos like this. Thanks.